Those videos for our trunks asking me how can we use SDL in C++, even though SDL is written in C. And I also want to go into how I'm doing this sort of library independent abstraction. And the first thing I implemented with this new paradigm is a timer. And the way it works is I make this abstract timer class with the expected ways I want to interface with the timer of any given specific type. So I make virtual classes like interval to return the interval. If it's active, it's a single shot timer. Set the interval, set whether it's single shot. This is a little more complex. I won't talk about this. Just don't worry about that. And then the timer ID, which there's some stuff I want to do with that. Virtual void start it with a certain number of milliseconds, or just start it. If you've already set the milliseconds, stop it, and then set the callback. And this is actually inspired by SDL's timers, and it's the style that I want all the timers to go by, even with other libraries, at least for now. And then you have a virtual destructor, which you make a destructor virtual so that it'll call. Well, watch this. So I'm not going to talk about this timer SDL, but we inherited from abstract timer, but I want to get focused on the virtual destructor and why this works. So if we actually go down to when we actually have a timer class, now this is the class we use when we're actually programming our application. The timer class will actually, in its constructor, see we have a abstract timer P. But the cool thing in C++ is that we can use that abstract timer and we can actually put into it the more specific timer types based on a preprocessor definition. And that's how we can have, like, if we're using SDL, we can have a timer SDL. And with that virtual constructor, the abstract timer class, it will call this child destructor, make sure that we do any further cleanup that we're supposed to do, even though this is actually only an abstract timer. So it's being able to call a subclassed objects destructor when you're using the parent class data type, but you're filling it up with a subclass type. Got it? All right. And the reason why that works is because in our child class, we're using all the same methods. So they share that pool of methods. There's nothing really added except for like additional variables. So we can actually look at the timer SDL and the additions I made to it. Now bear in mind, this is the first commit for this new edition, so it might not be perfect, but you know, you get a constructor destructor, which by now I think I don't even have any code in there anymore. And you can we actually have variables, like we have the interval, we have a specific SDL timer ID, and single shot, and whether it's threaded, and the threaded thing I just don't want to go into. I should go into it at the very end. So yeah, you get actual content in here in these functions for when we're setting stuff and whatever. Yep. All of this will be defined in the implementation CPP file. You can set the callback again. Yeah, the threaded thing I don't want to talk about. And then static callback, internal callback. I really gotta talk about that. That's more complex. That's just as complex, if not more, than the threaded thing. But I do want to explain it. I have to. And then event type. See, these are SDL specific things. Yeah, I know. I'm making a video. Thanks for ruining it. All right. No. Whatever. So. Herp derp. Well, I'm going to keep going. So, the event type and the callback stuff is all handling SDL internal stuff under the hood, so that we don't have to worry about any of it. And I should explain it though. Like, all your SDL timers need a callback function, and I have a static callback function, so that works for any of the timer objects, but which basically handles some internals while also calling a personal callback function that you want it to call. That's the best I can explain it right now without having used it for like almost a week. And the event type is, we register a new event type just for the timers with the SDL events. So it's like a special event type. And this is just a little thing to organize the callback function that we specify, our parameter that we specify that we'll receive in the callback, the interval, which no one has to worry about, and being able to call the callback function automatically as this parentheses like function operator. Let's look at the implementation. So the event type variable immediately gets initialized via this register event type function, which just calls SDL functions like SDL register events 1 and does some error checking there. It'll return the event type into this variable. Just some basic initialization there. So yeah, this is the static callback. So this is a static function global to all the timer SDL objects. This is what we pass into SDL itself as the timer callback. And what this will do is we actually pass the specific SDL timer object as the parameter, and we cast that. This is like a C style cast. There's probably better ways of doing it in C++. And we use the internal callback. And here's what the internal callback would do. It would do some specific stuff we always want done. Now this is like, once again, specific to SDL. So you always want to return the interval at what you want your next timer to happen at. Or if it's a single shot, you would want to return 0, which will stop it. Threaded stuff I don't even want to talk about. This is bad tab. I don't know what happened there. But anyway, since this is the single thread mode, and this is actually executing in a separate timer thread in SDL, SDL automatically creates a separate thread for this. So to keep it all single threaded, we push an event to the event loop, which will be checked for in the thread's main event loop. And I have like a special format for this. I pushed the callback structure as data 1. We don't really care what the code is. We're just using our event type. So you would have to know about SDL stuff to know what I'm doing here. I don't want to explain everything. And if it's single shot, return 0. Otherwise, return the actual interval, right? Starting the timer is just a matter of stopping it if it hasn't already been started. And I've actually analyzed the internals of SDL2 to make sure that we can do this and it'll be okay, to say the least. I don't know, like I looked at all these race conditions, but it turns out that no matter what, it's going to be okay. And then we use the add timer via SDL with these proper milliseconds, the static callback function, this object's, and if there's no timer ID, if it failed, that this is just handling an SDL issue. Should probably do something even more intense here. I don't know. So yeah. If there is no timer ID, it means there's no timer, so don't even stop it. Otherwise, we SDL remove the timer ID. If it's not successful, we bitch about it. And we set the timer ID to 0. So this is our way of knowing that there's no active timer. Set the callback. This is pretty obvious. Okay, so when I made this commit, I actually have a program that'll compile in here. So these are in main, and this will actually run SDL's main thread timers and its multi-threaded timers. So the only reason why you would want a multi-threaded timer is if you would want to change the interval, like in real time in the callbacks, have like this variable changing timer interval. But you got to be careful with that, because now you're running that code in a separate thread. You want to make sure you don't have any sort of race conditions modifying variables that the main thread has access to, or the main function. You know, it just so. But I left it as an option. I don't want to talk about the implementation. Like, I don't even want to talk about any of this. But there is an example here, and you could just take this entire file. This is timer.cpp. You might be able to just compile this. In fact, I'm going to try to do that right now. So this isn't shared. There should be like a core now. It should be called abstract core. And now we can just, I think we can just, where did it go? There's actually a complex compilation process for this, for me at least. And I don't remember where I put it. Great. Not cool, man. I don't know where it went. I could check my desktop. It is somewhere. I know it. I know it is. Oh, I must have put it in here. No? Maybe it's like a note. Yes, I did. So where is this? How come I'm not seeing it? Demonstrate super awesomeness. How come I wasn't seeing that in this commit? Oh, this must be newer. So this is how I compile this thing on my Mac. That'll push out, wait. You gotta be kidding me. I actually have to use this, I guess. Can I actually use that? Yeah. So I'll even explain this long ass command. Basically, this will just demonstrate some main threaded timers and stuff. So going at a very fast rate, just because I wanted the test to be fast at one point. So if you want to know exactly what I'm doing here, I'm going to explain it. So I have SDL2 installed on my Mac via Homebrew, but that is like release type library. I wanted a debug type library so I could look at the debugging symbols and actually, like, if I'm GDBing my program, be able to see where in SDL my code is running as an actual file and line number. So for that, I downloaded SDL. I got 2.0.3 here. I just built it with like, using dot slash configure and make, and it ends up going to this build slash dot libs. And on OS X, if you want to actually have this to be the preferred execution library location, so when we're executing it, not when we're compiling it, you got to use this .ild library path environment variable. And as far as compiling it with those libraries, I'm just compiling. I had to make sure I compiled SDL with debugging symbols, so I had to add a -g into the make file, or actually I exported C flags with -g before configuring it. But then I compiled the actual program with debugging symbols, C++11. Can't remember why I use C++. Is it even using C++11? Oh, probably because I like initialize variables in the class definition at least. And this is just because when we actually use this code from SNES Tracker's perspective, we're going to be compiling it from not the actual live, like this is the actual file, so I just made it look like, include core / timer / C. You wouldn't be able to do that from the current directory. That's why I have that include directory is ... And then I specified the preprocessor timer SDL so that we use an SDL timer in this implementation. And then I use my library location and include location, compile with SDL2. It's as simple as that. This video is like way more convoluted than I wanted it to be. Got interrupted by my mother, but that's okay. So it's better than nothing, I hope, and it at least must have showed something. It's never as quick as I want it to be. I wasn't planning on doing this, but I know it's better to at least try to get some knowledge out there about what this is, what I'm trying to do with these abstractions, basically so that we can have one expected way of a timer working universally in our application. And if we want to use a different library, like I'm really thinking about using Qt, I don't want to use Qt exactly, because if I ever have problems with it, I'm going to have this Qt only app, and I want to be able to say, no, I have an abstraction behind it, so we can adapt some library into the abstraction, just like what happened here with SDL. So yes, in order to do this, you need to have specific knowledge of the library you're working with. You need to be able to understand it enough, not only to use it, but to see how to manipulate it into an abstraction, which isn't too hard if you've used it at least once. All right, I'm signing out. Take care. Peace out. Gotta go eat some.